If x is greater than 0 and y is greater than 0, prove that 2x cubed plus 2y cubed is greater or equal to x squared plus y squared multiplied by x plus y. So I'm going to start by multiplying out the double brackets, binomial expansion. So I'm going to have x squared plus y squared multiplied by x plus y. I'm going to bring down the x squared, stick on the second set of brackets, bring down the y squared, stick on the second set of brackets. X squared times x is x cubed, x squared times y is x squared y squared times x is xy squared, y squared times y is y cubed. And then I'm going to write this down on the right of the inequality sign. So I'm bringing down the 2x cubed and the 2y cubed and the inequality sign, and then this becomes this. Next, I'm bringing everything over the inequality sign. So the 2x cubed stays where it is, the 2y cubed stays where it is, the x cubed comes over and becomes minus x cubed, the x squared y comes over and becomes minus x squared y, the xy squared comes over and becomes minus xy squared, and the y cubed comes over and becomes minus y cubed, and this is all greater or equal to 0. Then I'm going to simplify. 2x cubed minus x cubed is x cubed, 2y cubed minus y cubed is y cubed. I'm going to bring down the minus x squared y and the minus xy squared, and that's all greater or equal to 0. Next I'm going to do factorization by grouping. So I'm going to factorize x cubed minus x squared y. So I'm going to have x squared multiplied by x minus y, and then I'm going to factorize minus xy squared plus y cubed, and I'm going to get minus y squared times x minus y, and this is all greater or equal to 0. Since I've got x minus y inside both sets of brackets, that's going to be one of my factors. So x minus y is one of my factors with brackets around it. I'm going to bring down the x squared and the minus y squared. So that's my other factor. So I've got x squared minus y squared inside one set of brackets, and I'm going to factorize this by using the difference of two squares. So the square root of x squared is x, so that's in the front of both sets of brackets. The square root of y squared is y, so that's in the back of both sets of brackets. And I have one to be a minus and one to be a plus. So I have x minus y times x plus y, and then I'm bringing down the x minus y, and that's all greater or equal to 0. So now I have x minus y multiplied by x minus y, which is x minus y squared, and I bring down the x plus y, and that's all greater or equal to 0. And as x is greater than 0 and y is greater than 0, this was given to us in the question, then x plus y must be greater than 0, and x minus y squared is greater than 0, so it must be true. So since this ends up being greater or equal to 0, this statement is true. And the most important part here is that anything squared is going to be positive. So anything squared must be greater or equal to 0. So that's how it ends up being true.